This lesson is going to be about properties of radicals. As you can see, this is going to be much shorter than the properties of exponents was. We only have two of them here. We've got the product property of radicals and the quotient property of radicals. And overall, they're essentially saying the same thing, they're just for two different operations. So what the product property is saying is if you have two terms that are being multiplied under one radical, you have the option of, instead of looking at that as one big problem, you can split them up and take each of them, give each term their own radical, and then multiply them afterwards. And then for the quotient property, it's saying the same thing except just for division. If you have two terms that you are dividing underneath one radical, you can choose instead to give each term, the numerator and denominator, their own radical and then divide them afterwards. So the idea for this, let's do a product property of radicals first. Let's say I asked you to take the square root of 9 times, say, 4. If I asked you to take the square root of 9 times 4, what the product property of radicals is saying is you technically have two different options. You can go ahead and take 9 times 4, which we know is 36, and then after multiplying those two terms together, you can do the actual square rooting, which the square root of 36 is 6. So that would be our answer here. Your other option, though, and that's what the product property of radicals is saying, is your other option is you could instead look at this as you have a square root of 9 and you have a square root of 4, and after you've square rooted them, you can multiply them, meaning instead of multiplying first, square rooting after, you can square root each term separately and then multiply. So the square root of 9 we know is 3, and we know the square root of 4 is 2. 3 times 2 also gives us the exact same 6 that we got the other way. That's what the product property of radicals is saying. It doesn't matter which direction you want to do that in, whether you want to do the multiplication first or the square rooting first, you'll still get the same answer. That's what it's trying to say. Quotient property is meant to be the same idea. So for a quotient property example, we'll just use the same numbers, but let's say you are asked to the square root of 9/4. Well, you may not be very comfortable with fractions, so this may be where you really care about these properties a bit more. If you know the square root of 9/4, you can just do that immediately, but if you take, you can't take really 9 divided by 4. You could do it as a decimal, I guess, if you want to just use it all in your calculator. But if you did it in a decimal, or if you just look at it as 9/4 the fraction, the square root of that is going to be 3/2. But let's say, for argument's sake, that you don't have a calculator on hand, and you don't know the square root of 9/4 off the top of your head because fractions aren't your favorite thing. Well, the great thing about the quotient property is that instead of trying to figure out what the square root of a fraction is or what the square root of a decimal is, just look at this problem as the square root of 9 divided by the square root of 4. Then it's not such a big problem because you know that the square root of 9 is 3, and you know that the square root of 4 is 2. And then you just copy over the fraction bar and you've got your answer, right? 3/2 is the answer. So you don't have to use a calculator that way. That's when the quotient property, or when these properties of radicals in general, can become very useful. Let's take a look at one more example because I want to point out that these properties do work in both ways, in both directions. Meaning, for example, let's say that I asked you to take the third root of 3 times the third root of 9. Well, as that stands, that looks like a tough thing to do, because if you go to your calculator and try right now, the third root of 3 does not come out nicely. The third root of 9 does not come out nicely either. So not only is your calculator still going to give you a nasty decimal, but you have to have a calculator basically, because these don't come out to a nice number that you can just do in your head. But if we look at our product property of radicals, this does work both directions. So I have given you two different terms with their own radical, but we could choose to combine them into one large radical, allowing us to multiply first. Meaning, instead of writing it as the third root of 9 times the third, or the third root of 3 times the third root of 9, we could instead write this as the third root of 3 times 9. And then we know that 3 times 9 is 27. And if you look at the third root of 27, that is something we can truly do because the third root of 27 is simply 3. So now we don't necessarily have to use a calculator to figure that out. So I just want to point that out, that the properties do work in both directions, so you can take two terms under one radical and split them up, but you can also take two terms that have separate radicals and combine them. The key is you have to make sure they are the same type of root. Meaning the only time that this doesn't work is like if I ask you to take the third root of 3 times the square root of 9, neither of these properties have anything to do with that because one of them is a third root and one of them is a square root. The type of roots, the type of radicals need to be exactly the same for this to work.